All right, day 3 notes. At the top, you see you have two general forms of sine and cosine where you have A, B, C, and D listed. A is your amplitude, which is just the height of the curve from the midline. B is your frequency, which is how many full curves you'll see between 0 and 2 pi. C is what's known as your phase shift, which is really just a horizontal shift. And D is your vertical shift. So that's your up and down. Now notice that curve shifts horizontally, or the curve shifts horizontally, C units to the left if this value is positive, or C units to the right if it's negative, which is what we've been used to all along with transformations on graphs. It's counterintuitive with the left and right shifting. So if the equation is in this form where you see how B is on the inside of the parentheses as opposed to the outside, you need to factor out the B in order to figure out the phase shifts. Otherwise, you're not going to get the right shift. We also have some helpful hints for how to deal with looking at one cycle of a curve. The one that I tend to use is determining the endpoints of the period of the function prior to any shift, and then I just shift everything based on what it tells me to do. So just some practice looking at amplitude, frequency, period, phase shift of just any old function. Look at A. The amplitude is 4. The frequency, which is your B value, that's 2. Your phase shift, which stands for C, is technically negative pi over 4, which means left pi over 4 units. And then, almost lastly here, this plus 7 means you're going up 7. That's your D. Something else you should note is that there's a negative in front of the 4, which just means you're reflecting in the x-axis. Okay, so those are all the transformations that took place on cosine. Okay, if you look at the next one though, notice how there's a 2 inside the parentheses. That means I should factor that out first before I talk about any of the transformations, otherwise I'll get them wrong. Okay, so the amplitude is 10. The frequency is 2, which means that you're going to see 2 full cycles of sine over 2 pi units. Your phase shift is a positive 2 pi, which means you are shifting to the right 2 pi units. And then lastly, the minus 1 here means you're going down 1 unit. That's your vertical shift. Okay, so we're going to put these transformations into practice and graph some stuff. Okay, so first of all, just answer some questions about this function. We're looking at sine of x, and it looks like we have a phase shift, meaning it's moving horizontally. The amplitude, which is just the leading coefficient here, since nothing's listed, our amplitude is just 1. The frequency, which is the B value, again, you see nothing listed there. That's just 1. Which means that the period must be 2 pi units, because period is always equal to 2 pi divided by the frequency, but the frequency was 1. So 2 pi divided by 1 is 2 pi. So over 2 pi units, you're going to see 1 full cycle. The phase shift is negative pi over 2, which means you're going to shift the graph left pi over 2 units. Or if you want to think about this in terms of degrees, 90 degrees. Now when we set up our axes below, technically each box is going to be worth 30 degrees, or pi over 6 units. So every 3 is pi over 2, or 90 degrees. So technically when we're shifting left pi over 2, we're actually shifting left 3 boxes, if you want to write that down, based on how we set up our axes. Okay? So let's graph this, and then we'll get back to the whole 1 full cycle will occur and domain and range. So setting up our axes, every 3 boxes is pi over 2. okay, between 0 and 2 pi, and our amplitude is just 1. So I'm going to make 2 boxes on the y equal to 1. All right, so the first thing I'm going to do is just graph our sine curve before the phase shift. So sine curve is going to start on the x-axis and end on the x-axis. If you think about how sine looks like that, right? So halfway in between, it's got to hit the x-axis. So halfway in between 0 and 2 pi is pi units. Halfway in between those x-intercepts, it's going to go up. So halfway in between 0 and pi is pi over 2. Up to our amplitude of 1 is 1. And then halfway between pi and 2 pi, it must go down to negative 1. So this is our graph. Actually, I'm going to do this dashed because this is not the function yet. Okay, so again, in dashed right now, what I've graphed is y equals sine of x. There's been no shifting. I'll change my color here. I'm going to take each of these points now and shift them to the left pi over 2 units, or that's really 3 boxes. So I'll even label this here. This would technically over here be negative pi over 2. So I'll take every one of those 5 points and shift them to the left. 3 boxes. Okay, and there you have it. So I'll label this. This is just, we're just going to graph one cycle of it. This would continue on and on and on. But this graph is now y equals sine of x plus pi over 2. So one full cycle occurred on our graph from negative pi over 2 to 3 pi over 2. The domain of any sine curve is all reals though, because this will continue on and on. The range, if you look up and down, was just from negative 1 to 1. Now I need to answer some questions about it first before I go through and graph it. So the first thing I got to do here is recognize that the frequency, this 2, needs to be factored out. So I'm going to rewrite this as y equals 3 sine of 2 times x plus pi over 6. So pi over 3 divided by 2 gives me pi over 6. That's how I got that. So the amplitude of this graph comes from this leading number, which is 3. The frequency is this number here, 2. So that means between 0 and 2 pi, you would see 2 full sine curves. But if I only want to see one sine curve, that's where the period comes from. The period is always equal to 2 pi divided by the frequency. So in this case, 2 pi divided by 2 is just pi. So over pi units, I will see one cycle of sine. Now the phase shift, which is its horizontal shift, is determined by this number right here. Now it's going to be the opposite sign, so negative pi over 6, which means it's moving to the left. And it may be helpful for you to convert back to degrees from time to time. So if you think of negative pi over 6, that's the same thing as left 30 degrees, which when we set up our boxes down here is going to be one box. Okay, so let's set up our axes here. So since I'm only shifting by pi over 6, I'm going to keep the same scale that I normally do. So every 3 boxes is pi over 2, which makes every box pi over 6. Okay, and make sure I go high enough so that my amplitude is 3 on the y-axis.
Now, what I'm going to do first is graph y equals 3 sine of 2x. So notice that I don't have the shift or anything. I'm going to graph this, and then I'm going to move everything over pi over 6 units. So I'll do this in a lighter color, I guess, so that we're keeping track here. I'll do it in, I don't know, I'll do it in this like pink color. So sine on this curve is going to be pi over pi units because that's the period. So sine is going to start on the midline at 0, 0 and end, so one cycle is going to end at pi 0. So that means halfway in between these points, sine's going to hit the x-axis again. Now, keep in mind how a sine curve normally looks. I'll just kind of sketch it off to the side over here. Looks like that. And there's been no reflection in the x-axis, so it's going to go in between these 2 points halfway up to 3, because that's my amplitude. Oops. And then halfway between pi over 2 and pi, it's going to go down to -3. So if I lightly sketch in, I'll just dash this. This is the function before it's been shifted to the left 30 degrees. Now keep in mind, again, that each of these boxes is worth 30 degrees, or pi over 6. So I'm going to take each of these points then, of my pink function, and move them to the left. One box. Oops. So I'll do this in a solid navy blue. Oops, I don't like that curve. Okay, and then to finish it off, I'm going to label my final product. So this is y is equal to 3 sine of 2x plus pi over 3. And there you have it. So again, the navy blue curve is where I ended up here. The pink curve I used to help me see what it's going to look like before I shift it to the left. So let's try another one.
All right, so we're going to graph 2 sine of x plus 3 over the interval of 0 to 2 pi. The amplitude here is just 2. The frequency, which is the coefficient on that x there, is 1. And the period is equal to 2b, or 2 pi divided by the frequency, which is just going to be 2 pi. So over these 2 pi units, you're going to see one full sine curve. There is a plus 3 here that isn't, in the parentheses. It's really outside of that function, which means we're going to shift up 3 units. So that means the equation of the midline is y equals 3, because normally it would be at the x-axis. Okay? Alrighty, so let's do this. So in order to graph, we're going to draw in the midline, so then we can base everything off of that midline. So again, we're going to draw in a line such that the line is y equals whatever the vertical shift is, which in this case it was y equals 3, and this is known as the midline. Okay, so I'll do 1, 2, 3, 4, 5. Just kind of graph some stuff there. Here is going to be our midline. This is y equals 3. Now, along the x-axis, I'm going to label every 3 boxes as pi over 2. Okay, so over 2 pi units, you're going to see one full curve. Now, instead of basing the whole sine curve on the x-axis, I'm actually going to base it on the midline here, because then I will have shifted everything up 3 units. So sine, again, normally looks like this, okay, but we're shifting everything up. So instead of starting here at 0, 0, it's going to start on the midline at 0, 3. Instead of ending at 2 pi on the x-axis, it's going to end at 2 pi on y equals 3. So start and end. Halfway in between, it's got to hit the midline again, which halfway between 0 and 2 pi is pi. Okay, and then halfway in between each of those points, then you're going to see a max and a min. So halfway between 0 and pi is pi over 2. So don't forget that the amplitude is 2 units though. So that means I'm going up to 5, as that's a distance of 2 from the midline of y equals 3. Between pi and 2 pi, I'm going to go halfway in between again at 3 pi over 2 and go down 2 units, or 2 full units to 1. Oops. Okay, I'll do a nice smooth curve. Oops. Okay, and then I'll label this. This is y equals 2 sine of x plus 3. So the domain is all reals, and our range is now from 1 to 5. Okay, there's a couple questions below. What is the maximum value? The maximum value you're going to hit is up here at 5, and your minimum value, the lowest the function is going to go, is 1.
Okay, so now I've turned to page 11 here. There's the number. And I'm looking at this function, which has a lot going on to it. I've got a reflection in the x-axis, an amplitude of 2, a frequency of 2, a phase shift of negative pi over 4, and then it shifted down 3. So I threw a lot at you. And I'm going to graph one cycle of this. So let's first answer some questions about it. The amplitude is 2, and the frequency is 2, which means the period, which is 2 pi divided by 2, is pi. So if I want to see one cycle of this, it'll be over pi units. The phase shift is negative pi over 4, which means it's moving to the left pi over 4 units, which is 45 degrees, if that helps. So since I'm shifting by negative 45 degrees, or to the left 45 degrees, the way I normally set up my axes, where every box is worth 30 degrees, is not really conducive to shifting things around by 45 degrees. So here is an instance where I'm going to change the interval on the x-axis. So let's see, can I get down here? Okay, so instead what I'm going to do is make every 2 boxes pi over 4 units. So that's 45 degrees. So then if I keep going, this is 2 pi over 4, or pi over 2. This is 3 pi over 4. And then lastly, this is 4 pi over 4, or pi units. So when I'm graphing the period of this graph, here's the pi units that I'm looking at. Okay, now the amplitude here is going to be 2. So make sure I have enough room to go to an amplitude of 2 on the y-axis. I have to keep shifting because otherwise I don't want it to get too small. I'm trying to look up here and see what I have to do. So I'm going to graph this curve without any shifts first. So that means, if you need to write it off to the side, I'm going to first graph y equals negative 2 cosine of 2x. So notice I've eliminated the phase shift and the vertical shift. Okay, so what this is going to look like, I'll do a different color here. Between 0 and pi units, I'm going to have one of these cosine curves. So maybe I'll just temporarily put a line here so you know this is where I'm going to stop. Now, since there's been a reflection in the x-axis, I'm not going to start at positive 2. I'm going to start at negative 2 with that amplitude. which means over here where I kind of sketched in a line so I knew where to stop, at pi, I'm going to end at -2. Okay, I'm going to get rid of this for a second. Okay, so then, because of how cosine looks, halfway between these points, so this is how many boxes? 1, 2, 3, 4, 5, 6, 7, 8. Okay, so halfway between is at pi over 2. I'm going to be at a max of 2, which means then halfway between here, so this is a distance of 4 boxes, so right here and right here, it's going to cross the x-axis. And, oops, I don't like how that looks. Oopsies. I'm going to sketch in this curve. So again, that pink function is the function without the left or right or down, whatever, without the phase shift or the vertical shift. So now I'm going to take this pink function and I'm going to shift everything to the left 45 degrees and then down 3. Did I forget to mention that somewhere? Oh, here it is. It has to go down 3. Whoops, forgot to fill in the vertical shift. Okay, so I'm going to label in the negative direction because I'm going to have to move everything to the left pi over 4 units. So this is a negative pi over 4. I'll do it in green. Mix it up a bit. So again, I'm moving everything to the left pi over 4 units. And then I'm going down another 3. That's what it was, right? 3? Yes, 3. Okay, so this is what you're going to see me doing for the next few seconds. Okay, so what you see in green is the final answer. Sorry, my screen's getting all over the place. So I've got y equals -2 cosine of x minus pi over 4 minus 3. And just do yourself a nice little visual check. Does this look like it has an amplitude of 2? And you can compare that with your new midline right there at y equals -3. So from this midline, it looks like it's went up 2 units and it went down 2 units, so that's good. It looks like it's been reflected from where it was. So I did the reflection already in the first part. And I moved everything to the left pi over 4 and down 3, which makes sense why it looks like it's nice and centered around my new midline. So just be aware of what the midline is, because I could ask you a question like, what's the midline now of this function? Okay, if we're talking about domain and range here, the domain of any cosine or sine curve is all reals. And the range looks like it's between -5 and -1.